new rule of scene CSV. We can use the original definition of scene CSV to define 3 items in CSV file. The first one is the scene X file of each component, filling in the first 3 columns. The second is the hierarchy. Which one is parent, which one is children. The hierarchy structure we use attached to. The object attached to which object. The third is the relationship between the virtual machine and the physical machine. That is, which the actual axis of motion control car to control which virtual axis of the machine. You can use the old regulations, no problems. For standard operation procedure, right now we give 2 rules to define the scene CSV creation to let the usage more convenient, more easy. Right now on the screen you can see the GAC 14.csv, that is the gantry robot of a water jet machine. In the file folder D CMS GAC data, we can search GAC.csv. The previous we defined the GAC 14. Right now use GAC 14 to give these 2 rules. Let's copy it. Press the right button of the mouse, duplicate, and put any vacuum space position, and press the right button of the mouse. Okay, we have to find the folder GAC CMS GAC data first, and find a vacant space. Press the right button of the mouse and put it on. Here we have a duplicated GAC 14, and right now press the right button of the mouse, changing the name of it. We give the name to put R and real of the file name and press enter. Right now the new name is GAC 14 R.csv. Okay, let's press 2 times of left button to open the file. H14 foundation, Y14, Y component, X component, Z component, C component, B component, all the same. The hierarchy structure, okay. The new rule, we just specify this position. First of all, we handle the RGB errors. As we said in previous lectures, if the factory doesn't provide the drawing of RGB on the two original points. Then we have to use SolidWorks to create RGB by ourselves on two original points. Sometimes it takes times for the new user, seems too complicated. If we define the RGB errors and Cartesian original points already and give a default name, then we can use the default name to fill in these columns, and the system calculated according to the tool XYZ X Y R Z to do the transformations automatically to lower and locate the RGB errors at the TCP points. Then it's better for the user to use. Right now, I defined XORG.X as the R arrow, the red arrow of X axis located at the original points of Cartesian coordinates, the YORG.X as the Y arrows, green arrows located at the Cartesian coordinate original points, the ZORG.X as the original blue arrows located at the Cartesian coordinate original points. Right now, the first rule, let's use. So we change the X file to XORG, use the original X arrows. If we use this one as our system to calculate, then we have to fill in translocated columns in here as 99. This is artificial definition, 99. The system recognized 99 and calculated the matrix transformations for us automatically. And why we change to the original YORG.X. The same, we have to fill in translotate the column as 99. And the ZAR14 has to be changed to ZORG.X. And the translotate column changed to 99. Okay, this is the rule 1. Let's see what's the results as we adopt this file in CMS CAPP system. Will the system automatically calculate the matrix calculation and put the 3 errors at the TCP points as we wish? Okay, as finished filling in CSV file, we have to save file. Yes. And close the file. Yes. And save the name GAC14R. Save it. And always yes. After finished, we use scene input the GAC14R.CSV on the screen. First of all, we have to use the new to clear the buffer on the screen. So the scene disappeared. Then we use scene input, the folder CMS GAC data, and then the one we just adjusted is GAC14R, and pick it and open the file. You can see in here, enlarge it, RGB in the right position according to robot setting or tool setting 00 minus 245.3, rotating 90 degrees. Okay, so if everything is 0, you can see the two original points. Right. If no transformations, the two original points is at the intersection points between the rotating axis of C axis and the rotating axis of B axis. Right. Okay. This is the rule 1, to use the original defined RGB errors at the original points of Cartesian coordinates, which then are x org.x, y org.x, z org.x. Right now, continue to the second rule. We use GAC 14R as demonstration. The error is okay, but you can see the transrotate 0, 1, 2, 4, 5, 6, 7, 8 is the limitations definition. The 3 is and here. So the second rule is for better seeing transrotate. It's better to change the position, the tool position, jump to insert in this line. Thereafter 0, 1, 2, 3, 4, 5, 6 until 99 is better for looking, and give us OP to define the GAC scene definition. Okay, so how to do it? We just press the left button of the mouse and keep putting and move the mouse until the last line 16 and release left button. So the one we want to move will be marked. Then we use clip it up. It will highlight like this, and supposed to put at this line 18. Press the left button of the mouse and choose clip on. Clip up. It will then all lines be moved to 18 position. Right now, we move tool 14.x to line 8. The same, we just put the cursor of the mouse at the line at the front of tool 23 and press the left button of the mouse. And the same, clip it and choose the position 8, line 8, and press the left button and choose step it up. So the tool will change the position from line 23 to line 8. Okay, the same, we we let the mesh number in sequence 0, 1, 2, 3, 4, 5, and this is 6. The object in sequence 5 and 6. Right now you can see the transrotate 0, 1, 1, 1, 2, 2, 3. Okay, then before we move this up, the column we change according to the sequence, the 7 and the 7, and this transrotate is 4. What means 4? 4 minus 3 is 1. That means the up limit and the lower limit, the positive limit and the negative limit of the axis 1. That is the x-axis. The positive is 1684 millimeters. The negative is 0. So this one is 8. And the transrotate in here is 5. What means 5? 5 minus 3 is 2. That means this one define the axis 2, positive limit. This one define the negative limit of axis 2. Axis 2 here. What is x2? Axis 2 is y component. So the y component of this machine will move positive 100 millimeters. The negative limitation is minus 3936 millimeters. The rest all the same. So this mesh 9. This is mesh 9. This is mesh 10. Object 10. This is mesh 11. Object 11. 12, 13, 14. No change. So how to move it up? We can delete this one or move it up. Okay, we use delete it. Press the left button of the mouse and keep pressing the left button and move the cursor, the mouse cursor, down to the last space line and release the left button of the mouse. The system will mark the blank lines and put the cursor on any place of this area and press the right button and then choose delete it. Okay, this one the same. Press the left button of the mouse and move the cursor on it and press the right button of the mouse and choose delete function. Then everything in correct sequence. Transrotate 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 and 9. Okay, let's see if the second rule can work correctly. If so, then it's very convenient to do it. For next thing, CSV, we just copy these lines into the new definition and change the positive and the negative values. That's it. The dummy and the original .x is all default. The only thing we have to handle is the hierarchy structure itself. The axis actually moving components, X, Y, Z, foundation, tool, etc. Okay, then before we leave alteration, we have to save it. Yes. And close the file. Yes. And save the name GAC14R. Save it. Yes. Yes. Okay, after finished, we make a check of it. Now, how to adopt it? First of all, we have to use new functions to release the screen, and use scene input to see the folder CMS GAC data, and pick the file GAC14R and open the file. You can see everything okay. And let's see the movements. X, Y, Z, RB, RC is all the same. And the more we can see the Cartesian coordinate. The Cartesian coordinate, this is X, this is Y, this is Z. The X positive downward, the X negative upward. You have to see the limitation of Z. The Z limitation is only for 50. You cannot move too far, otherwise he will stuck, because it touches the limitation of Z axis. So this is X, the Y positive, you see the positive direction, the negative go this way, the Z positive this way, the Z negative this way. And most important is the rotation, Rx no move because it touched limitation. Notice Z, the Z no movements. The rotating about the y-axis, you see, positive. Negative. Positive. You use your right hand to see the rotation is correct or not. The most important, because this is not the 6-axis roller, the Z in rotation about the Z has a difference, a little difference. So we see rotation about the Z positive. Have you seen the rotating about the Z axis? This is the big difference between the 6 axis. It rotating about the vertical Z 001 vector directions. Okay, talking about the 2 new rules of CSV finished.